No problem. So we'll start with questions now. So my first question will be, what does it really mean when I say everything is an object in Python?
Sure. So it simply means that everything which looks simple, even like integers or functions, are actually objects with identity, type, and behavior.
Mhm.
You can pass functions around, assign them to variables, and inspect them at runtime. This flexibility is a core part of how Python works.
Mhm. Then can you just explain me like how does variable assignment work internally in Python?
Sure. So variables don't actually store the values directly,
Mhm.
they hold references to the objects. When you assign something, you're just making the variable point to an object in memory.
Mhm.
By this, the reassignments changes the reference, not the object itself.
Okay, perfect. And what is the difference between mutable and immutable objects?
Mutable objects can be changed in place,
Mhm.
while immutable objects cannot. This matters because multiple variables can point to the same object.
Mhm.
With the mutable objects, changes are visible everywhere, wherever the reference is being shared.
Okay, perfect. Uh, all right. So before moving to the next question, can you join the link that I have shared in the chat?
Sure, just give me a second.
Yep.
I'll be there. Um, yes, I have joined.
Yep. So the next question is, how are strings immutable? Cause I can do operation like this, right? See, I am changing this string. Then again, we are seeing that strings are immutable. Then can you just explain it? How is it?
Sure. So, strings themselves don't actually change in Python.
Mm-hmm.
When you do the operation, something like this s plus equals to a, as you have mentioned,
Mm-hmm.
Python actually creates a new string object and simply points the new string s to that particular object.
Okay.
So, when this is modified, when this s is hello a, this is going to be a new different object in Python.
Perfect. That's correct. Okay. Moving to the next question. What's the difference between double equal and is?
Sure. So, double equals actually checks the value,
Mm-hmm.
and is checks for its identity, which is the object in memory.
Mm-hmm. Okay. So my follow-up question will be, can you just tell me what will the output of this particular question in the screen?
Sure. So as I mentioned, double equals checks for the values. So the first one should be true.
Mm-hmm.
And the second one would check for the object in memory. So then it becomes false.
Okay. Perfect. Yeah. Correct. Moving to the next question. What is decorator in Python?
So a decorator is a function that modifies or extends the behavior of another function
Mm-hmm.
without actually changing the source code.
Okay. Perfect. Can you also write a quick example in the screen?
Sure. Do you want a specific decorator or I can name it whatever I would like to?
You can name it my decorator maybe.
Okay, sure. So here I am writing my decorator as you stated.
Yeah. Just a moment. I will remove the previous one. Okay. Yeah. Now
Sure.
start. Yeah.
Is it good?
Yeah.
Okay, great. So I'll create a wrapper if that's all right for you.
Yeah.
I'll do nothing as it is just a simple function which I'm trying to write. I'll just write a before and a after log.
Sure.
Before phone call, and the other one would be after the phone call, and in between that, I'll call my funk.
Mm-hmm.
So here, just a second. Yeah. Okay.
Mm-hmm.
So this will be a simple wrapper,
Mm-hmm.
and I'll just do nothing but return the wrapper here. Okay. So this is a short decorator which I'm trying to write.
Mm-hmm.
Now I'll just write a simple dummy say hello function, which will just print an hello statement.
Okay, sure.
Just like say hello. If you would like to rename anything, please just let me know.
Yeah, sure, sure.
Okay. And as we want to use a decorator, I'll use my decorator here. Okay.
Perfect.
So this should be a short snippet. In case you want this to be executed, I would like to initiate this if you
Yeah, yeah,
want.
sure, sure, sure. You can invoke it. Yeah.
Okay, sure. So yeah, that's it. So
Okay.
this would be a short example of
Uh,
decorate.
yeah, can you run it?
Sure. Mm, yeah, I've done it. So as you can see, if you would like some explanation, it would be like whenever I call this say hello,
Mm-hmm.
Python actually called the wrapper.
Mm-hmm.
The decorator intercepts the function call,
Mm-hmm.
runs the additional code before and after the original function, and then returns the result.
Yeah.
So in our case, when I ran this say hello, it printed all the things which are currently there in the wrapper, and then it came to its execution. So the func was called in
Mm-hmm.
between the before and after calls, and it gave us the print statements.
Okay, perfect. Um, I got it. So moving to the next question, can you explain how does dictionary work internally?
Sure. So dictionaries internally use hash tables.
Mm-hmm.
Python calculates a hash for each key
Okay.
to find where the value should be stored. So when you look up a key, it uses the same hash to quickly relocate or to locate the value, which is why dictionary operations are usually very fast.
Ah, that's perfect. Yeah. So, why must dictionary keys should be immutable? What's the necessity of it?
Sure. So, as I stated in the previous question, the dictionaries relies on a stable hash.
Mm-hmm.
So, if a key is changed after the insertion, the dictionary wouldn't be able to find it again. So, this makes that the keys should be immutable.
Okay. Okay. Sounds good. Moving forward, um, so just a follow-up question on that. So, what will this print? So, you don't need to execute it right now. First, you need to tell me the output. Maybe you can comment it out. Yeah.
Sure. So, let me see this. Okay. So if I analyze this, what I could grasp right now is that all the three keys which I can see, true 1 and 1.0,
Mm-hmm.
will have the same hash. So
Okay.
the assignments which are going on will kind of overwrite the previous one. So
Mm-hmm.
only the last value remains.
Okay. So, what will the output? Can you just comment here?
Sure. So the key becomes true and the value becomes this one. So I'm just simply copying and pasting it so that it's
Yeah. Yeah. Okay. Yeah. Now, let me check this. I'll comment this first. Yeah. Yeah. You're correct.
great.
Okay, moving to the next question. Why are lists not hashable but tuples are?
Okay, sure. So, as we know that lists are mutable
Hmm.
and tuples are immutable.
Hmm.
So, the hash could change only in the mutable object, which is the list.
Yeah.
And in case of tuples, it stays the same.
Okay. Sounds good. Sounds good. Uh, yeah. Moving to the next question. How does Python manages memory?
So, Python mainly uses reference counting to track objects in memory.
Hmm.
When an object's reference count drops to zero, it
Hmm.
becomes eligible for a cleanup, and that Python can free that memory.
Okay.
This is known as garbage collection.
Okay. Okay. Then again, my follow-up question will be, uh, why does Python have a garbage collection then?
Sure. So, the main crucial part is because reference counting alone cannot handle the circular references. In case you're trying to do, let's suppose you initialize the string, a list A, and
Hmm.
you're trying to append A itself.
Hmm.
So then you're doing a circular reference.
Okay.
Even if A goes out of the scope, the reference count will never be equals to zero. So
Yeah.
the garbage collector detects the cycles that are no longer reachable.
Okay. Can you write down whatever example you were saying?
Sure. So I was
You
just
can.
trying to say that
Yep.
A is just the list which was initialized, and then I'm trying to do this A dot append A.
Okay.
So this is a circular reference which I was trying to refer.
Yeah. Perfect. Good example. Yeah. Now moving to the next question. What is the difference between shallow copy and deep copy?
Sure. So a shallow copy creates a new object, but the contents or the references inside still point to the same object.
Hmm.
And in a deep copy, it creates a new object and recursively copies all the nested objects.
Okay. Okay. Mm, good one. Okay. Moving to the next question. Can we add a list to a set? Is it feasible? I have just pasted example in the screen. If you can see, is it possible to do it?
So if you think about it, um, the short answer should be no. We cannot add a list to a set because lists are mutable.
What's the reason?
Because lists are mutable?
Okay. Yep. 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 Mm. Sure. Do you have any workaround to fix it?
Um, so a workaround should be that we can convert the list into a tuple
Hmm.
so that a list can be converted to a tuple and safely be stored in a set. So if I, let's suppose, try to write a list, maybe 1, 2, 3, and I initialize a set S,
Hmm.
so then I can do s dot add and convert the list to a tuple. So s dot add and then tuple of the list.
Okay. Okay. So you are just suggesting that I should convert this A to a tuple and then we should probably add it. So firstly,
Yes,
let's just try to run it, whether it's giving an error. Yeah,
sure.
so we have an error of an assemble type list. Now, what's your solution? You are saying to convert it in a tuple.
Tuple,
Yeah,
yes.
can you just write how you can do it?
Yes, sure. Can I modify the same one?
Yeah, yeah, you can modify the same one. Yes.
Okay, let's try to run this.
Yeah, yeah, perfect. It's working now. Maybe we can write print statement to see how it looks.
Sure, sure, sure.
Yeah, that's perfect. Okay, moving to the next question. What methods are called during object creation of a class in Python and in what order?
Sure. So during the object creation in Python, methods are called in the following order.
Hmm.
The first one would be new, which
Okay.
is called first.
Hmm.
The next should be the init. So the new is responsible for creating a new instance of the class and returning it.
Hmm.
The init initializes the newly created instance. So
Okay.
in case of new does not return an instance of the class, init will not be executed.
Okay. Sounds perfect. Yeah. Moving to the next question. Can you explain async and await in very simple terms?
Sure. So they allow Python to pause a function while waiting for input output
Hmm.
or IO operations and run other tasks instead. This improves the throughput for IO bound workloads without using multiple threads.
Okay. Yeah. Got it. Sounds good. Mm, so my follow-up question will be, does async make Python faster? Does it help it in any way?
I don't think so. It's like it doesn't speed up the CPU bound work,
Hmm.
but yeah, asyncs can help by avoiding free time during input output operations, allowing the other tasks to run while waiting.
Okay. Okay. Sounds good. Okay. Moving to the next question. What is the GIL or global interpreter lock in Python?
So the GIL ensures that only one thread is executed at a time.
Hmm.
It just simplifies the memory management but limits true parallelism for CPU bound threads.
Okay. Mhm. So when does multi-threading still help in Python? When would you choose multiprocessing instead?
Sure. So multi-threading is useful for IO bound tasks like network requests or file operations,
Hmm.
where threads spend a lot of time waiting.
Hmm.
For the other question around multiprocessing, I would choose it because for the CPU bound workloads where you need real parallel execution across multiple CPU cores.
Hmm. Okay. Okay. Sounds perfect. Okay. Now we'll move to some output-based questions. Okay.
Mhm.
Um, Let me paste one question for you in the chat.
Sure.
Uh, the screen can.
And Roshan, if you don't mind, can you just plug in the charger?
Yeah.
Thank you.
Yeah. No problem with that. Okay. So here's the question in the screen. Can you check what will the output of this?
Sure. So, as I can see, when creating B,
Hmm.
we are saying A is to 3. The dictionary stores the value of A at that time as the key.
Okay.
So it becomes 1 is to 3.
Okay. Okay.
Later
So
on,
can you also comment out whatever answer you have?
yeah, sure. Like I was just trying to say that whatever changes we do after the initial key value does not affect the dictionary.
Yeah. That's
So the answer should be this.
okay. Sure. Okay. Let's execute it.
Sure.
Okay. That's correct. Um. Fine. Moving to the next question. Mm, Let me paste it here. Okay. What will be the output of this question?
Okay. So here you're trying to initialize A and append 3. Okay. So the tuples are immutable,
Hmm.
but the list which is there on the first index, which is 1 index, is mutable. So we can modify the list. So do you want me to write the output?
Yeah, you can write it. Yeah.
Sorry. Yeah. So it should be 1, comma, and the list could be modified. So it could be 2, comma 3. Yeah,
Yeah.
this should be
Perfect.
the output.
Perfect. Okay. Uh, Now let me execute it. Let's see. Yeah, perfect. That's correct. Yeah. So now we have one DSA questions for you. So this will be the last question of the interview,
Okay.
and let me paste the question here.
Okay.
Hmm. So can you read it and ask any questions if you have, if it is not clear. So in short, you need to create subsets, okay, of whatever
Okay.
nums list you have.
Mm-hmm. Okay. Just give me a moment to go through it and
Yeah,
maybe I
yeah,
can.
sure, you can read it out. Yeah, maybe you can read it out. I can also hear. Yeah.
Okay. So it says that given an integer array nums of unique elements, return all possible subsets, the power set. The solution set must not contain duplicate subsets. Return the solution in any order.
Hmm.
So in the first example, which I could see, 1, 2, 3, it is trying to iterate through all of them. So it
Hmm.
would be one empty, then 1, 2, 3, single, single, and then 1, comma 2, 2, comma 3, 1, comma 3,
Yeah,
and then 1, 2, 3.
yeah. So for this question, you have 10 to 15 minutes with you. You can take your time. You can and whatever is going in your head or in your mind, so you can just explain to me and each and
Sure.
every steps how you are proceeding. Yeah.
Sure. So by looking at this question, the first example at least, what I was thinking is,
Hmm.
so I'm just trying to give the brute force approaches which are coming into my mind, and maybe we can go ahead with the optimizations.
Yeah, sure.
So the first approach would be like, as I want all the subsets
Hmm.
for such a short ones, which are like 1, 2, 3, 1, 2, 3, 4, or 5, things like that. What I could do is I could iterate one by one over the objects
Mm-hmm.
by sizes. So let's suppose I wrote a loop, okay? In the first one, first is always going to be an empty one, which is we already know. We'll
Mm-hmm.
do that. And after that, I'll write the size as one and then iterate. So it will print one, two, three. As
Okay.
soon as I'm done with the iterations and I reach the end of the list, I'll increment the size to plus one.
Okay. Okay.
I'll increment the sizes until I get the size of the whole superset.
Mm-hmm.
Okay.
Mm-hmm.
So I'll traverse, then I got the sizes now 2. So it will do 1, comma 2, 2, comma 3, 1, comma 3.
Okay.
These are the possible subsets.
Mm-hmm.
And then it will now move to 3 when there is only one possible case, which is the actual set.
Mm-hmm. Yep.
But what I could think of is this is kind of possible for less number of less, like when there is a less number of items in the list.
Mm-hmm.
But when it exceeds a lot, it could be a lot of complex approach where we are trying to use for loops.
Yeah. Yeah.
But yeah, that could be one of the solutions, but because it is going to work for both the examples which are mentioned
Yeah.
to
I
us.
agree. I agree. Then what should be the most efficient solution for this?
So if I could think of, this seems to be something with backtracking and a DFS approach.
Yeah.
So my key idea would be for every element we'll either make either of these choices, which would be first to include the element in the current subset
Mm-hmm.
or to exclude it.
Okay.
So by these exploration of these choices, we'll do the recursion and we'll generate all the possible subsets.
Yeah. Sounds good. Yeah. Can you just start with the coding? Um, or you want to have some more explanation?
Uh, no, I think we can start, and maybe later on, if I have something, I can share it with you.
Yeah, sure. So I will remove the text above. I think question is clear to you, and I will just keep the example in the screen. Okay. And
Okay, sure. Maybe you can comment the
yeah,
above
yeah, sure, sure, sure. I have already commented. You can start with your
so
code.
that I can go through it
Yeah,
whenever
yeah, yeah. No
I
problem.
need some clarity. So I'll maybe name it as subsets because it sounds more, uh, you know, appropriate to me.
Yeah,
So we are getting the nums array, right?
yeah.
Okay. So first one, nums. Do you want me to declare the types of these, or it's fine?
It's fine. You don't need to uh, do the typing thing.
Okay, and which will give a list. Okay, so I'll just write a subsets one. As I said, we are going to traverse recursively. So I'll initialize two lists. One will be the answer list, and one will be the subset list.
Okay.
Okay, so this is just a basic initialization.
Mm-hmm.
Now we'll do the DFS part.
Mm-hmm.
So I'll now write def DFS. I'll just name it as DFS. If you want me to be somewhat elaborative, please just let me know.
I know it's fine.
Yeah, sure. So this would be DFS of an I. And what I'll do here is
Mm-hmm.
if I'll check, I should be always greater than length of the nums.
Yeah. Mm-hmm.
So I can write an if loop saying if I is greater than equals to the length of nums. Okay.
Mm-hmm.
Whenever this condition is being met,
Mm-hmm.
I want to append to answer.
Okay.
So I'll kind of do. Are you okay with me trying to explain each one of them, or you
It's
know?
fine. Whatever you think is appropriate, you can go ahead with that. Yeah.
Okay. So now here I'll do this particular thing, and I think it should be it for this particular if.
Yeah.
So I'll just okay, sorry. Okay, so this is it for this part.
Hmm.
And then, whenever this iteration is completed,
Hmm.
I'll try to append this nums into the subset.
Okay. Okay.
Okay, so subset dot append nums of I. Okay. After this is done, as we want a recursive approach, I'll call this DFS again,
Okay.
but with an incremented value. So DFS would be called again. After this is done, I'll pop that particular subset from my subset list.
Okay. Okay.
So then it becomes subset dot. Okay. After this, again, I have to recursively call the DFS.
Hmm.
So which becomes DFS I plus 1. So I think by these recursions, it should be 8. So let me return the answer list. Okay, so this is it for now, and then I can return the DFS. Um, okay. Um, I think this sounds good. Let me just go through it again.
Yeah. Sure. 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 Take it.
Uh, okay. It seems good to me.
Hmm.
So what I'll try to do is, do we want to run this or what needs to be done?
Yeah. So you will need to run this with the examples given above. So
Okay.
like nums 1 2 3. Okay. And you can see the examples that we have written above, right?
Okay,
Just
sure.
use that and call it. Yeah.
Okay. Yeah. So I think that should be it. Shall we try to run this or?
Okay, you're already written. Okay, perfect. Yeah. Just print it so that okay, it is giving you the output or not. Um, yeah, you should print it. I think it's not giving any output,
Yeah, yes,
so
yes,
just
yes.
print it.
Sure. Shall I?
Yeah, just print.
Okay. I thought you were doing something because it is shows your cursor here.
Okay, solid. Sorry. Okay, now let me run it. Yeah, that's perfect. So we are getting the results. Can you also paste the second example?
Sure, sure, sure. And it's 0. I'll just write it.
Yeah.
Yeah.
Okay. Let me execute it again. Yeah, that's great. I think you solved it. Yeah, so I think that brings us in the end of this interview, and it was very great interacting with you, Sivanika. Do you have any questions for me?
No, I think it was overall a good experience for me as well.
Mhm.
And yeah, hoping for something positive from your end.
Yeah, sure. So maybe the HR will get back to you with the
Sure.
feedback. Yeah, sure.
Okay.
Have a great day. Bye bye. See ya.
You too. Thank you. Bye.
Thanks. Bye.